Alright, this video is going to be all about the different types of chemical reactions and how to identify them and determine what the products might be of a reaction. There are 5 basic types of chemical reaction. Now there are some others that would fit into one of these basic categories, but generally speaking there are 5 basic types of reactions. And what you can do is you can look at the formula given of the reactants to help you determine what the products will be. So in the following slides I'm going to go through the different types of reactions and show you general formats to look for in order to predict the products. The first type of reaction is a very basic reaction that's called a synthesis reaction. Your general equation for a synthesis reaction is 2 elements get added together to form a compound. You might want to remember that. 2 elements coming together to form a compound. An example is over here at the right. Iron plus oxygen comes together to form a single product, iron 2 oxide. Okay, another thing that we have is down here at the bottom we have magnesium coming together with nitrogen to form magnesium nitride. A synthesis reaction can be characterized by multiple reactants in a single product. The opposite of a synthesis reaction is a decomposition reaction. To decompose something is to break it down, and that's exactly what we're going to do. The reactants of a decomposition reaction typically are a single compound, and that single compound will break apart into multiple parts. Sometimes they can be elements, sometimes they can be compounds. The key thing to look for again is one reactant and multiple products. To the right we have an example of a decomposition reaction. Calcium carbonate breaking apart into calcium oxide and carbon dioxide. Also, water will break apart into its component parts, hydrogen and oxygen, through a decomposition reaction. The third type is possibly the most confusing. A single replacement reaction takes place when a single element cuts in with a compound and replaces one of the parts, and like will replace like. For example, the metal cation will only be replaced by another metal that's trying to step in. The example that I like to think of is down here. Say we have a couple who are at a dance and they're together, and a new guy comes along. He's going to step into this relationship and assume the couple role with the woman and leave the guy out all by himself. Another way to think about it is, say, at a high school dance. You're dancing with a friend of yours and someone else better comes along. That guy steps in, dances with your friend, and you're left all to yourself. Well, it's not quite as biased as a dance partner or something like that. It follows something called the reactivity series. The diagram that we have over here at the right is the depiction of the reactivity series. Potassium at the very highest level is the most reactive of the metals. And the rule is you can only replace someone as part of a compound that is less reactive than you. So potassium will replace any of these metals on this list. Sodium will replace any of these metals except potassium. In the case where we have something like KCl plus sodium, because sodium is trying to take the place of potassium, this reaction will not take place. The reaction will not proceed. So if you were to mix sodium with potassium chloride, all you would end up with is potassium chloride and sodium. No reaction would take place, and it would be a physical mixture, not a chemical reaction. A double replacement reaction is exactly how it sounds. 2 compounds are mixed together, and the result is the cations and the anions switch partners. What I like to think about here are 2 different things. You can think about this as kind of like a square dance, or you can think about it as maybe like an old 70s swingers party. A party will come in, switch partners, and then leave. These typically are very easy to balance, and one specialized type of double replacement reaction is called a neutralization reaction. A neutralization reaction takes place when an acid is mixed with a base, and it always produces a salt and water. The diagram right here depicts one of those things happening. Hydrochloric acid mixing with sodium hydroxide produces water and sodium chloride, a salt. The 5th type of reaction, basic type, is called a combustion reaction. Unlike the other reactions that we talked about, where we had a very generalized looking format in terms of what we have at the beginning and what we have at the end, a combustion reaction always, always, always has a hydrocarbon reacting in the presence of oxygen to form the same two products, carbon dioxide and water. The dead giveaway that you have a combustion reaction is that your products will be carbon dioxide and water. The only thing that will change from one combustion problem to the next is the formula of the hydrocarbon, and therefore the balancing. The last part with reactions that we're going to touch on is aqueous solutions where reactions are taking place. An aqueous solution is one in which a solid or a gas is dissolved in water. And there's two parts to an aqueous solution. The solute, that is what gets dissolved, and the solvent. Well, the solvent is the dissolver. In most cases, especially in this class, the solvent is going to be water. Water is considered to be the universal solvent, and anything that's ionic or polar covalent will dissolve in water. When two aqueous substances come together, a double reaction or a double replacement reaction is the one that occurs. And one of three things will be formed during that double replacement reaction: either water, a solid precipitate, or gas. What we just had was an overview of chemical reactions and the basic types and how to identify them. Be prepared to identify chemical reaction types in class tomorrow.